So this is Chapter 3, Section 5, Equations and Lines. So it's a good idea to have a lot of your notes in front of you to refer to, but most of the problems are basically straight up applications of knowledge we have about lines. So we're asked to graph y is equal to 1/4 x minus 3 and 2x plus 3y using its slope and y-intercept. So we have y is equal to 1/4 x minus 3. So just looking at the equation in its form, we have the slope is 1/4. And it's going to be good to remember this as rise over the run. And the intercept is 0 minus 3. When I say intercept, I mean to say the y-intercept. So how are we going to, we know that a single point and a fixed slope define a line. So how are we going to plot or graph a line using these two bits of information? Well, let's just do it graphically over here. So I'm just going to put right here in the middle of this digital space just an arbitrary point. This is just the conceptual part. And I'm going to label it as 0 minus 3. Now the slope tells me that I have a positive run of 4. So if I start this direction and I go over 4 units in the positive direction, so remember when I say 4 units, that's 1, 2, 3, 4 spaces in the positive direction, because 4 is positive. Then I've done a run of 4, and then the rise is 1 again. So on the x-axis, this is the positive direction. On the y-axis, that's the positive direction. So clearly, that's the negative direction on the x and the negative direction on the y. So it says now I go up and I rise 1. So I go to the end of the line I've drawn, and I'm going to go up a space of 1. I mean, that's not perfect, this is just conceptual, and I'm just going to say that's about 1 right there. So that's 1 unit, and there I will find another point. Well, what will that point's coordinates be? Well, I'm going to add, starting with my original point, I'm adding 4 units to the x, and then starting with my original y, I'm adding 1 unit to the y. So this new point is 4 minus 2, and you literally just draw a line through those points conceptually. I know I didn't quite hit it there, but this is just the conception. So there's 2 ways you can do this. You can use this little hint I've given you right here and just start with your given point. So first thing you do, find your slope. Remember, the numerator is the rise, the denominator is the run. Find one point. The easiest way is the y-intercept in this case, and draw a little triangle. Go over 4, up 1, and if you're on graph paper, then you'll already find another point and you'll draw a line. Another way to, so let's actually do that with graph paper. So let me grab this here. Maybe. Come back over. Start a new sheet and paste it in. So let's do it in real life here. So our slope was equal to 1 over 4, and our y-intercept, and that's easy to find because it's always going to lie on the y-axis, was 0 minus 3. So let's get a color here. So 0 minus 3, so all I do is go down the y-axis, so this is the y-axis up here. This is my y, and this is my x. So I start, here's my origin at 0, 0, so I go down minus 1, minus 2, minus 3. So right there is the point 0, minus 3. And then it says my run is 4 in the positive direction. So I got 1, 2, 3, 4, so that puts me right there. And then I go up 1. So right there is my next point. And I just simply draw my line. Not that way. I'll draw my line through those 2 points. And that's good enough for me right there. So that's an easy way to do it. Another way is just point addition. So here's a second way. So it's called the adder point method. I don't know who calls it that but me, but that's what I call it. So you do the adder point. So really what you're looking for when you're going to graph something on a sheet of paper is you need 2 points. So you're given an actual point on the line. So this is an actual point. And then we're going to add what is known as the adder point. Now the thing to remember about the adder point is that it probably does not lie on the line. But I can use it together with an actual point that does lie on the line to get another point on the line. And you may actually already be anticipating what I'm about ready to do, because we literally just did it in the previous screen. So how do I get my adder point? My adder point, sorry about that, my adder point is gleaned from my slope. So my slope is 1 over 4, which is rise over run, which is conceptually y over x. So my x value is 4. So my slope gives me my adder point. So my slope is 4 for the x and 1 for the y. And literally I just add coordinates. I'm adding here now, not multiplying. 0 plus 4 is 4. Minus 3 plus 1 is minus 2. And I get another point on the line. The only thing that you have to be careful with is the adder point is not a point on your line. So you have to start with an actual point. It could be. The adder point will be a point on your line if the line goes to the origin. That's the only time. Then you add your adder point. Maybe I should put point in parentheses. And then you get another point on the line. And you have 2 points, and you can graph it. Another way to do this is just to do vertical addition. So you start with your actual point, then you add, or right underneath of it, your adder point, and then you just do vertical point addition. Minus 3 plus 1 is minus 2, and 0 plus 4 is 4. And these are the 2 points on your line. So again, I emphasize, and that's kind of the reason I'm writing the adder point in a different color, The outer point is not a point on your line unless your y-intercept is 0, 0. Then it's actually a point on the line. Otherwise, you just use it to start with the given point plus adder. This is plus equal new point. And by that I mean a new point on the line. So let's do another one. So get us some clear space over here. So here, again, there's so many different ways to do this. But you're supposed to, by the objective, we're supposed to use its slope and its y-intercept. So 1, again we're on number 1, we have 2x plus 3y is equal to 12. So I have to convert this to slope y-intercept form. That means solve for y. So again, 3y, I'm going to move the 2x term over. When it's across the equal sign, it has to change its sign. And then I'm going to scoot the 12 over to the end. And then I'm going to divide each term by 3. So I get y is equal to minus 2/3 x plus 4. So my slope m is equal to minus 2/3. And my y-intercept is 0 and 4. So let's do it. So my actual point is 0 and 4. I'm going to use the adder point method. So remember, this is my y-x. So my x value is 3. And my y value is minus 2. And I'm going to add those two together to get another point. So 0 plus 3 is 3, and 4 minus 2 is 2. So here I have 2 points, 0, 4, and 3, 2. So let's go over and plot 0, 4, and 3, 2 on our graph. Again, 0, 4 is going to be our y-intercept, so that makes it really easy to find. I just go along the y-axis, and right there is 0, 4. And my next point is 3, 1, 2, 3, and 2. There's 1, 2, 3, 1, 2. So right there's 3, 2, and my line goes through. Well, I didn't do a very good job at all. Maybe I'll just start right there. If I start right there, and then you can just draw arrows at the end of it indicating that it goes on forever and ever. It doesn't really matter. It's just a line segment. That's all we can draw anyway. Notice that the slope of my first line, this slope is positive. And this slope is negative. And we can tell just by looking at the direction of the lines and its slant. Remember, an ant walking from left to right going downhill, negative slope. You don't have to fight against gravity. You have to going uphill, positive slope. You have to fight against gravity. And indeed, we got a negative slope right there, so everything checks. So now we're going to have yet another way to write an equation of a line. So in this case, and this is going to be a really important point, is remember the general equation of a line, and it works for every single line, is ax plus by is equal to C. That works for every equation. Every single type of line, including vertical ones. Y is equal to mx plus b. Every line except the vertical ones can be expressed this way. This is called the slope Y-intercept. And the next one we're going to do is going to be called the point slope form. So if we're given this 2 points, let's start with 2 points. 2 generic points. So I have x, I don't like the way I wrote that x sub 1, y sub 1, that's my first point, and x sub 2, y sub 2. So I know that the slope m is equal to y1 minus y2 over x1 minus x2. So if I use the slope m, what I'm going to do is the following. I'm going to go ahead and clear the denominators. I'm actually going to derive an equation for this particular line using this fact right here. So I'm going to clear the denominators by multiplying both sides by x1 minus x2. And then that's going to be multiplied by m. And I get y1 minus y2. So that's going to be really important. So that gives m times x1 minus x2 is equal to y1 minus y2. And now I'm going to do the following. I'm going to say I'm just trying to make this the same, y1 and x1 be any point. So I'm just going to label them x and y. Any point that lies on the line. Now that's very important. Those points, they're not just any point that lies on the line. And let x2, y2 be a specific point. Then this equation becomes x minus x2 m is equal to y minus y2. And because I've let x1 and y1 be any point, so why bother with the x2 and the y2? Let's just relabel them again as x1 and y1, and I get x minus x1 times m is equal to y minus y1. So all I did is relabel. Literally all I did is I relabeled x1 as x, y1 is y, x2 is x1, y2 is y1. It's just a relabeling. Nothing has changed from this particular form, just relabeled. And that indeed is our point slope form rather. So if you're given a specific point, x1 and y1, and you know the slope, then the general point slope form of the equation of the line is y minus y1 is equal to m times x minus x1. Remember, y1 will be a specific point that you're given. x1 will be another specific point that you're given. So let's go ahead and use that in some examples. It's really not that difficult. You just have to its derivation may have shocked you. It's not. It's very. The reason I'm saying that is I remember it's like, wait, is that legal? You're relabeling things. Doesn't that change your nature? But in mathematics, it doesn't ever matter. As long as you state the reason for the relabeling and relabel uniformly, then it's fine. And that's exactly what we did. So let's use the point-slope form. So again, this is called the point-slope form. I'll write it up here for us. Point-slope form. Again, this only works when it does not work for vertical lines, because vertical lines do not have a slope that exists. It's y minus y1 is equal to m times x minus x1. So you are given the slope m and a point x1, y1. So whenever you're given those two pieces of information, the slope and a point, then you can immediately use this formula, the point-slope form, to write an equation for the line. And that's exactly what we're given here. We're given a point, 0, minus 3, and a slope, m is equal to 1/4. And they say, well, write an equation of the line. So this is my x1, this is my y1. So y minus y1. So remember, the minus here is inherent. These two minuses here are inherent in the formula. So here, my y1 is minus 3, and it has to bring that minus 3 along with it. It doesn't get to use the minus that's already there. My slope is given as 1/4, and then my x is free, minus x1, which is 0. So we can simplify this. This becomes y plus 3 is equal to 1/4 times x. And that's it, you're done. I have a lot of students go ahead and solve for y, but listen, if you solve for y, what are you going to get? You're going to leave the point-slope form of your line and get the y-intercept form. And they're wanting the point-slope form. So hint, whenever you're asked to find an equation of the line and you're given a point and a slope, use the point-slope form. So let's do some more examples. So I'm taking it now that you've written down the formula on your notes. I'm not going to rewrite it down. And we're given a point that lies on the line is 2 minus 3. Now in your reading, this may be labeled as P 2 minus 3. You can ignore the P. That P is just telling you it's a point, but literally you should be able to look at this ordered pair, and what else is it going to be, right? It's a point in the coordinate system. So I don't know if my math lab is doing that or not, and that's a point, and a point on the line, not any old point, and our slope is equal to minus 3/4. So we have y minus, so this is x1, y1. Again, I have to write in my minus 3. I cannot use the existing negative there, is equal to minus 3/4 x minus x1. So this does require one small bit of simplification, and that's it. The answer is y minus a minus 3 is plus 3 is equal to minus 3/4 x minus 2. And you're done. That's it. Finito. You're done. That is a perfectly valid equation in point-slope form. Yeah, it doesn't look like a y-intercept form because it's not y-intercept. It's point-slope. Let's do one more. It won't hurt, I don't guess. So here we're given, again, we're given a slope and a point. So as soon as you're saying, write an equation, and it doesn't specify, it just says an equation, you get to choose. The only thing you should really choose here is the point-slope form. So it's much easier. So in this case, we have a slight complication because we're given 2 points on the line, and I need the value of m. That's okay. I'm going to label this as x1, y1, x2, y2, and our slope is given by the formula y1 minus y2 over x1 minus x2. And it doesn't matter. I could have designated this first point as x2, y2, and the next one, x1, is y1. You get to choose that, but here's our formula. So let's go ahead and use that. So y1 is 0 minus, what's y2? It has to bring that negative along with it. My x1 is 4, and my x2 is minus 4. So this is equal to 0 minus a minus 5, which is 0 plus 5. And the next one is 4 minus a minus 4, which is the same as 4 plus 4, which is 8. So m is now 5 over 8. So you're given 2 points. Which one do you choose? Either of the two. We have y minus y1 is equal to m times x minus x1. Now we're just plugging in. Remember, y and x are variables. My y1 is 0, and my m is 5/8. My x is a variable, and my x1 is 4. So this simplifies to y is equal to 5/8 times x minus 4. And you don't have to do anything. That's perfectly fine as it is. So just to review here, we could have done this other ways, but I think this is the most straightforward way, is you use the 2 points in the formula for m to get the slope, and then choose either of these 2 points. It does not matter. It does not matter. And you're going to get an equivalent equation. So had we chosen, just so some of you are kind of freaking out, oh no, I've got to choose. Let's actually choose this point instead. So I'll do a different color. So we have y minus y1 is equal to m times x minus x1. And we're going to choose these 2 points. Well, y is minus 5. And x is minus 4. So that gives me y plus 5 is equal to m times x plus 4. And what is my m? I forgot to write my m in there. You can write it at any point. My m is 5/8. And it turns out that these 2 equations, even though they look different, are equivalent. They have the exact same solution sets. So indeed, if you were to have chosen this point rather than this point, your equation will look different. That's okay. I'm prepared to deal with any point you choose. This one is not any better than this one. So they are equivalent equations. And so don't worry about that. So here we go. Let's actually do a screenshot here. And import it into So we want to find an equation of the line graphed. So we've got a lot of ways to do that, but notice we just did that when we were given 2 points in coordinate values. So I can literally use the exact same procedure I just did in the previous problem by finding out the coordinates of these 2 points. So let's see if we can figure out the coordinates of these 2 points. So my x value here is, here's my thing, this is a 3. And my y value, so what I'm doing is I'm going perpendicularly down, and I find that my corresponding x value is 3. Now I'm going a perpendicular line to the y-axis, and I find the corresponding point is 5. So the coordinates of this point is 3 and 5. Now let's do the same thing for this point. I'm going to go vertically down, and I find that my x value is -1, and then I'm going to go perpendicular to the y-axis, and I find my y value is 2. So now I literally have 2 points, 3 and 5, and -1 and 2. So let's find the slope. I will call this x1, y1, and this is going to be x2, y2. So my slope m is y1 minus y2 over x1 minus x2. So that's equal to 5 minus 2 over 3 minus a minus 1. So 5 minus 2 is 3. 3 minus a minus 1 is 3 plus 1. So that's 3/4. So that's my value of m. So m is equal to, I'm going to use this over here. So m is equal to 3/4. So now I can choose either one of my points. I'm going to choose my point here to be 3, 5. Now that's my x1, my y1. So again, I use y minus y1 is equal to m times x minus x1. The next step is just plug and chug. Y minus, what is my y1 value? It's 5. What is my slope? My slope is 3/4. And my x is a variable, and what is my x1? 3. And we're done. That's it. That is an equation of that particular line. Okay. Now we have another applied problem, which I'm going to go ahead and take over to our drawing space, because we will want to use the graph, I believe. I'll go ahead and take it all the way to there. Okay, sorry for the interruption. Doing this during office hours, and sometimes people need to contact me, in which case you can't really pause a live stream or a live recording, so I just pause it and clip out that area and start all over. So here we are with example 6, and it's an applied example. So we have the Las Vegas area was hit hard after the housing crash of 2009. In the fourth quarter of 2009, there were 15,710 home sales. And in the fourth quarter of 2014, there were 12,680 home sales. So the home sales are going down in time. So you can imagine the slope will be negative. Use these figures to predict the number of home sales in the fourth quarter of 2020. So my y value is going to be what we're looking for, number of home sales. And then my x value is going to be time. And in this case, I'm going to make things easier for us. Time starting at 2009. So my first point, xy, is going to be in 2009, which is going to be my 0 value, because that's where we're starting, and 15,710 is the number of home sales in that year. I literally just dotted my 10 there. Oh well. And then my second point occurs in 2014. So 2014 minus 29 is 5. So that's 5 years after 2009. And our home sales have declined to 12,680. So now we have 2 points, and we want an equation of the line. And I'm going to say mathematical observation or knowledge pays off. So I'm going to pose a question to you. Look at this first point right here, 0, 15,710. Does that strike you as in somehow important? I'm going to give you a hint. What is the first coordinate? Or another way to say that, what is the x value? So if a light bulb went off, you're going to realize that when I have an equation, if I want to choose the slope y-intercept form, y is equal to mx plus b, that this right here is precisely the place where the line crosses the y-axis, because if you recall, 0b, I thought I chose a different color, is this b right here, and this is the y-intercept. Now we could clearly go ahead and develop and use the point slope format, but in this case let's go ahead and turn it into y is equal to mx for mx plus b, because at some point we want to use this to predict the number of home sales in the fourth quarter of 2020. So that's going to give us a time value, an x value, since 2019 of 11. So I want to plug in 11 once I find the values of m, and I already found the value of b, and compute what the resulting y is predicted to be. So here we go. We have to find the slope. So I don't want to use that color. I want to use maybe a yellow. So 0, 15,710. That's 1 point. And another point is 5, 12,680. So I'm just going to go ahead and choose this to be my x1, y1. It doesn't matter. You could have chosen that to be the x2, y2. And this is going to be the x2, y2. And my slope m, again the formula is y1 minus y2 over x1 minus x2. And that gives me 15,710 minus 12,680 divided by 0 minus 5. So 15,710 minus 12,680 turns out to be, it's kind of a nice value, 3,030, and 0 minus 5 is minus 5. So 3,030 is evenly divisible by by 5, by minus 5. So when I divide minus 5 into 30, 30, it goes minus 6 times 30, 0.0306. So it's minus 606. So that's my slope. That's my m value. That's something I expect you should be able to divide 3030 by -5. So my equation, y is equal to mx plus b. We already discovered our b value was 15,710. So it becomes y is equal to minus 606 x plus this value here that I grabbed from this point, $15,710. So we're asked again to predict, so that's the equation. I've got this graph over here, but we're not going to use it. Use these figures to predict the number of home sales in the fourth quarter of 2020. So our starting point is 2009. So 2020 minus 2009 gives me 11. So that's my x value. So all I do is y is equal to minus 606 times 11 plus 15,710. This is going to be a negative value, and I get an answer of 9,044 home sales. And what are those home sales? Predicted in 2020. I have no idea if these values were just made up, if this is any way indicative of the reality, but if it were, and the data were taken from real life situations, and the home sales were linear, then this would be something you could use to plan your future. And that's one of the beauties of math, is it gives us an ability to literally see into the future. I mean, that's what's going on. I'm hoping most of you will vote. I will probably send out something reminding people. I won't say anything about party or anything like that. It's inappropriate. But of course, that's what they're doing right now with the polling, is trying to see the future of November. And the polls are very, very accurate if. There's a big if there. And if you take a stats class, you'll understand what that if is. The answer pretty much is, it depends on if the random samples of the poll respondents are a true random sample. And if it's a true random sample, an unbiased sample, then our polling data is very, very good. Of course, right now, it's still 2 months out from the election. But if you haven't registered and you just turned 18, this is one definitely to vote for. I was out of the country, I believe, when I first voted way back ages ago, and always vote. Okay, let's do number 3. Find an equation of the line containing the point. Oh, this is a good one. So, find an equation of the line containing the point 4, 4, and parallel to the line 2x plus 3y is equal to 7. So you say, oh my gosh, how am I supposed to do that? So like always, we've been given a puzzle. So we've got to put together the pieces of our puzzle and figure it out. So in a situation like this, I mean, for an exam situation, you should have already seen a problem like this and already had time to figure it out. I don't want you trying to necessarily figure this isn't really difficult, but this is something I wouldn't necessarily want you to figure out on an exam. So first, what do we know about two lines being parallel? So two distinct lines, that means they're two different lines, are parallel. Is that what they're asked for? And remember, The image here is a line going this way and another going the same direction, but separated by some distance. And what do we know? So just by looking at it, we can immediately say if they have, and what do these two lines have in common? The same slope. The same slope. And what makes them distinct? If these were two lines, they would have different y-intercepts. Where they actually cross the y-axis has to be different. And of course, every horizontal line is parallel to any other horizontal line. But of course, in that case, it's going to have a different y-intercept. And every vertical line is parallel to any other vertical line. In this case, most vertical lines, most, not all, do not have y-intercepts. There's only one that has a y-intercept. Then you look and make sure they have different x-intercepts. So what do we need here? I want to find an equation of a line. So it's going to go through the point 4, 4. And it's going to have the slope equivalent to this line. So let's go ahead and find out the slope of the line 2x plus 3y minus is equal to minus 6. So as always, we're going to solve for y. That gives me 3y is equal to minus 2x minus 6. And now I'm going to divide every term by 3. And that's going to get me y is equal to minus 2/3 x. Minus 6 divided by 3 is minus 2. So my slope here is minus 2/3. So I have a point and I have a slope. Let's use the point slope formula. That'll be x1 and y1. So y minus y1 is equal to m times x minus x1. Well, y minus 4 is equal to minus 2/3 times x minus 4. And that's all you have to do. And that is a perfectly good equation for the line that passes through the point 4, 4. There's other ways to do it. It looks to me like on my so we want to write the equation in standard form. There is one more thing to do. So this is point slope form. That's the easiest. So we have to convert this to the form ax plus by is equal to c. So we're not quite ready because the question asks us to write the equation in standard form. So that's okay. So what we're going to do is come on down here, and I'm going to rewrite my equation. Y minus 4 is equal to minus 2/3 x minus 4 in parentheses there. So I'm going to use distribution. So minus 2/3 times x times minus 2/3 by 4. So this is going to give me y minus 4 is equal to minus 2/3 x minus 2 times minus 4 is 8/3. So minus 2/3 times 4 is equal to minus 2/3 times 4 over 1, and you just multiply numerator and denominator. So now all I have to do is move the constants, see are the constant terms, move the constant terms to one side and the x terms to the other. So I'm going to take the minus 2/3 x and move it over, and it is going to become a 2/3 x. My y term is going to stay over there. Now I'm going to move my minus 4 over, and it becomes a 4 plus 8/3. So I'm almost done. The only thing that is required here is that I simplify what is 4 plus 8/3. Well, that's pretty easy. All we have to do is find a, let's just do it a different way. Let's do it even a better way. So I have two denominators, right? And they're both 3. So an even easier way to do this is I always get an equivalent equation if I multiply every term by 3. So 3 times 2x, 2/3 x, so I'm multiplying both sides times 3. So 3 times 2/3 x is equal to 2x, and 3 times y is 3y. And 3 times 4 is 12, and 3 times 8 divided by 3 is 8. So I get the equation 2x plus 3y is equal to 20. And that's a perfectly good equation in the form ax plus by is equal to c. So just notice here, when you multiply the negative 2/3 times the negative 4, that's how we got rid of the negative in the equation. Okay, let's do another one. This is another good puzzle here. So find an equation of the line containing the point 4, 4, and perpendicular to the line 2x plus 3y is equal to minus 6. So two lines are perpendicular. If the product of their slopes is minus 1. Another way to say that is if you're given if M1 is one slope, then minus 1 over M1 has to be the other slope. But this is easier. If M1 is one slope and M2 is another slope, then the product means when I multiply them together, I get minus 1. So find an equation of the line containing the point 4, 4 and perpendicular to the line 2x plus 3y is equal to minus 6. So let's go ahead and convert this into slope y-intercept form. So I have 2x. There's a lot of different ways to do this. Is equal to minus 6. I want to convert to slope y-intercept. So that's the y is equal to mx plus b. So I'm going to move my 2x term over and scoop my minus 6 over. Divide everything by 3. And I get y is equal to minus 2/3 x minus 2. So my slope m is equal to minus 2/3. So that means we want to find the slope of my new line, right? So M1 is the slope of this line times M2, it's going to be the slope of my new line, is going to be equal to minus 1. So I have minus 2/3 times M2, that's my unknown here, is equal to minus 1. So what do? I multiply both sides of the equation by 3. So my multiplying both sides of the equation clears the denominator. So 3 times minus 2 times, so what I do here again, multiply both sides by 3, and I've still got an equivalent equation. So 3 times minus 2/3 times m2 is equal to minus 2 m2 is equal to, and minus 1 times 3 is minus 3. So now I'm in familiar territory. I want to divide both sides by minus 2. So m2 is equal to minus 3 divided by minus 2 is equal to 3/2. And that is the slope of my new line. And does it say anything? Yeah, it says it says eventually we want the equation of the line in standard form. But let's go ahead and use point slope form first. We want it to go through the point 4, 4. So this is going to be x1 and y1. So y minus y1 is equal to m. In this case it's going to be m2 because I'm writing the equation for my new line, x minus x1. So y minus 4 is equal to my m2 value I discovered to be 3/2 times x minus x1 is 4. So again, we've got to simplify this over here. So have y minus 4 is equal to 3/2 x. I'm just using distribution again. And minus 4 times 3/2 is the same as minus 4 divided by 2, which is minus 2 times 3. So that's minus 6. So this is going to be really easy. So I'm going to move my 3/2 x term over here. It becomes minus 3/2 x. The y is going to stay because remember we want an equation in the form ax plus by is equal to c. So the y stays, but the minus 4 term is going to come to the right hand side. It's going to change its sign and join our 6. So the final simplification is going to be minus 3/2 x plus y is equal to minus 2. And that's the equation in general form. Ax plus by is equal to c. In this case, a is equal to minus 3/2. b is equal to 1, and c is equal to minus 2. And just wanted to show you that's the end of all of our problems. If you download the class notes, it's also in your textbook. These are literally copied and pasted from the textbook. I have forms of linear equations and some information about perpendicular and parallel lines.